This afternoon, we're going to talk about the re-engineering of the data center. Over the last 10 years, the definition of a data center has changed. Companies like Pinterest don't have a data center at all. To them, the API is the data center, and they just rent time on someone else's computers. PayPal and eBay, conversely, just announced a 650,000 square foot data center in Reno, own their own facilities in Utah, but also co-locate at companies like mine and at Switch in Las Vegas, and just signed a large deal with IBM Cloud. What's emerging is the concept of the hybrid data center. In this world, the choice is not between public and private cloud, or between co-location and building your own, but it's really a mix of all of the above. And companies will create this mixture by trying to leverage the strengths and avoiding the pitfalls of each of these models. Public cloud offers rapid scaling and a usage-based model, but it isn't for everyone, and it isn't necessarily cheaper. Private cloud offers some of the benefits of public cloud, but also claims to be more secure. But is it really? Are your security engineers better than Amazon or Google at security? And what about building your own data center versus co-locating? Is running a data center core to your business, or should you outsource it to someone who actually is an expert in it? And if you do that, how do you get the same level of control and the same visibility as if you're running your own data center? And should you even care? Whether you're considering a public or private cloud, co-location or enterprise, is the decision yours anymore as a technology leader, or is it really just a financial decision? Or with shadow IT, is the decision even being made at the executive level, or is it being made by somebody lower down in your organization? So today, the panel, we're going to talk about each of these models, the innovations that are occurring in each, and how you can use these models in a hybrid approach to increase the agility, increase the flexibility of your data center.
I believe one of the constant patterns of change that we've seen over the past 15 years of data center technology now is the move from proprietary purpose-built platforms to general purpose platform. And I do believe that a lot of this was really innovated by what I sort of call the massively scalable data center customers, eBay certainly being one of them, Microsoft, Facebook, Google, Amazon, et cetera. And I think now we're finally starting to see the opportunity to bring some of the innovations that we've seen leveraged in some of the most efficient, scalable, cost-effective data centers in the world to the mass market. Certainly a role that we're playing in there. And I think, if you think about yesterday's data center, the legacy computing model was purpose-built servers with specialized processors running a custom operating system with a vendor-specific feature set, right? So it was a vertically integrated stack. And, there are benefits to a vertically integrated stack, and there are also downsides, vendor lock-in being one of them. Also, the development cycle, the innovation cycle of a vertically integrated stack tends to be much slower, much longer, and much riskier than where you break apart that stack and innovate at each piece separately. So one of the biggest challenges we see right now is the network in particular. We believe that if you look at the networking model of today, it is sort of the server model of 1995, right? We've seen certainly companies moving en masse from mid-range computing systems to Linux on x86 or Windows on x86 in a heavily virtualized environment, and I would argue that it is the precursor to cloud computing as a whole. And I believe one of the biggest challenges that we've created for ourselves is as the rate and pace of change in infrastructure has moved very, very differently in each segment of the infrastructure, which is supposed to work in uniform as one layer that applications reside on, we've actually introduced more vulnerabilities from a security perspective, okay? So if there's one thing that's outpacing the majority of IT spending today, it's security spending, and the one thing outpacing security spending and technology today is the losses that we're having from security risks as well. So we've all seen it seems like Target and Home Depot and JP Morgan Chase were so long ago, and then it was Sony, and now it was Anthem in the past week here. These are not bright people who are heavily invested in and have amazing technology personnel and their capabilities. It is a fundamental flaw in the architecture that as an industry, we've propagated, right? From an infrastructure component industry, from a software industry, from an application development life cycle. And really, we believe the next wave of this software-defined data center allows us to change the architecture the way we have in the computing environment across the infrastructure and really address these needs.
James, who was talking earlier, is one of my biggest clients, second biggest client. eBay's number one biggest client. At GPI, what our charter is to run a competitive business, offering to our internal customers data center, cloud, platform services, all while driving bottom line results through cost avoidance, savings, and general business optimization and efficiencies. So what I wanted to kind of raise a little bit of awareness to is, and we talked a little bit early in the first panel this morning about measuring everything. Well, we're pretty fanatical about measuring everything as well. Especially when we're looking at things, and James alluded to this, when we start looking at our stack and whether we build or buy or lease or colo or hybrid, we really want to use metrics in everything that we're evaluating, because at the end of the day, it's economics that drives these decisions. Technology is certainly an outcome, certainly a goal, certainly something that all of us in this room want to drive, but underneath it all, we still need to make money, and we still need to avoid costs, drive efficiencies into the system, and how do you do that? So internally, when we're thinking about building and buying, whether our internal dollars per megawatt for building or operating the stack outside, and comparing that against the outside competition, for, let's face it, the infrastructure world, it's commoditizing, kind of you're referring to that, as it should be. And one has to be pretty large scale, kind of like us, to warrant building and managing infrastructure on your own. But even recently, our most recent data center project, we're actually partnering with somebody. So we own and operate 2 data centers. I think they're listed up here in Salt Lake City and Phoenix. Those are our properties. In the portfolio, we have about 60 megawatts total today. It's about 104,000 servers. But in Las Vegas, that's actually a colo facility. And the Reno project we just announced a couple weeks ago, that is also in partnership with a colo facility, because the cost of capital that they could bring to bear was better than ours, right? Using their capital was a better investment than ours. We're still providing the infrastructure at that layer, with the servers and the designs. We can talk about that a little bit later. But the partnership now is something that we're seeing as a trend that's happening. So even at our scale, we're starting to see the colo option, right, the kind of outsourcing of that build take hold. And also sort of on the left-hand side, I wanted to kind of draw your attention again to one of the other metrics that we use. It's near and dear our heart. My colleague and friend Dean Nelson, who runs our GFS organization, created this a couple years ago. It's called the Digital Service Efficiency Metric. And in short, what this is attempting to do is holistically measure our entire business, sort of on one bookend, the transaction, or where we make money, and on the other end, the lowest common denominator, the watt. And so we can actually measure through the DSE how we're doing with all the levers in between those things. So as we talk about reduction in PUE, search engine optimization, or even marketing investments, we can see the effect on that DSE metric. Are our transactions going up, or our revenue going up? And is our cost structure, our watts, coming down? It's in its infancy, even a couple years into it, but we're really using it internally to drive how we're making some better decisions. So as you can see, we're pretty passionate about using metrics, making data-driven decisions in what we do. Sort of the more data we have about our infrastructure, about the cost and the impact on the business, the more germane the options out in the marketplace, the more impactful we are to the bottom line, the better results we drive. So
I've been fortunate to be part of a journey in large web-scale private clouds. Whether you're in a private cloud or a public cloud, I think the way to characterize the macro trend that we all are going through is what I call infrastructure as code journey. And it can be described as, really in simple terms, it dawned on me, I was in my garage the other day and thought, these are really 3 stages that we're all kind of going through. It's the hand tool stage, graduating to machine tools, and then robots. But they each have, I think, a different characteristics with the promise of a significant step function improvement in speed, consistency, and efficiency. So perhaps I'll just talk about what are roughly the attributes of each one of them and how you graduate there. And there's really not a right answer, but it is just recognizing where you are. You start off with a domain-specific world where you have networks, you have systems, you have storage, you have domain-specific engineers that are working on it, and they have tools that they build to optimize those environments. Then when you graduate to electrical tools or machine tools, one important element happens is the introduction of what I call configuration management systems, such as Puppet or Chef and others. But the lines start blurring between network systems and storage engineers. You actually start hiring, or folks that are systems engineers are the same ones that are configuring JBODs and storage attachments. They're also configuring your VLAN and things of that nature. So those things start blurring. You still have element-specific management systems, primarily from the domain. But you get a step function improvement, like we talked about. The next stage, and I surmise that you can do that regardless whether you are in public or private, is API for everything. And what I mean by everything is the line starts blurring between applications and infrastructure. It's just configuration. And how you access whether an application or infrastructure is through an API. But you need something really important to do that, which is a real-time, metrics-driven feedback system. And there's lots of ways of doing it. I'm sure lots of firms have mastered that. But you need a real-time feedback system to make sure that API-driven world can actually be managed well. And the outcome, usually, is automated capacity management, auto-scaling, things of that nature, automated test and repair, the attributes of Simian Army, Chaos Monkey, what have you, and then ultimately monitoring. We don't have a NOC. It goes directly from the systems to our engineers over something we call PagerDuty, and with a high signal-to-noise ratio. But what you hire at that stage are software engineers with a context about infrastructure. But I'd like you to think about those 3 stages and see where you fall in and help usher in that journey.
I've been in the industry 35 years. I've lived out, been lucky enough to live in the middle of Silicon Valley that long. I've worked in a number of different roles. The last 12 years, I've focused my career solely on energy efficiency for data centers. In 2005, I built Intel's data center practice and deployed that globally. So I had the opportunity to do a great deal of work in Europe and China, and of course the United States. My focus at that time was primarily around airflow management. So when I hear the word infrastructure, for me, and especially as a member of Schneider Electric, I think chillers, UPSs, switch panels, all that equipment that maintains that IT equipment, allows it to run reliably. So one of the points, the diagram that you see here, the one CFD model, I've done probably a couple hundred CFD models. It models airflow and temperature transfer. That was a great tool to help us get through the basics, much like PUE helped draw attention to facilities overhead and how to reduce that. And as I began that work, the next phase was really to look at how do we use outside air, which is now becoming much more common. I won't use the word free air because it's not free. But the question then is, how much can I reduce my energy and carbon loads of my mechanical cooling systems? The maps that I provided there kind of indicate different areas around, at least the United States, that can potentially support this. One of the real change factors that's occurring right now, and we've seen assume you're all familiar with ASHRAE and TC 9.9 recommendations from 2011. I understand there's new recommendations coming, but what they did was open the door to give us the opportunity to start to build data centers that go beyond the freezing 60-degree facility that's extremely expensive to operate. Those were great for the IT manufacturers. They're the ones who set the principles of temperature and relative humidity, not science. The colder it is, the fewer pieces of equipment come back. So now the industry is moving the other direction, and we're looking at how can we perhaps eliminate mechanical cooling energy consumption? How can we, and this is almost heresy in the Schneider world, but how can we also operate without UPSs, right? My focus is on total energy reduction. So I'm not tied to PUE. I'm tied to the business value that represents. So I've done a lot of work. I spent many years at Intel. I was part of the project that developed the Node Manager technology, which allows us to throttle processors. That's just one tool that we have. But what's missing, or what's, I should say, still has some evolution to go, is the integration between those facilities infrastructure and the IT side. The importance of that is becoming more, it's becoming more and more important. And again, as we looking at the ASHRAE specifications and the idea of raising temperatures in our data centers, that is one great way of eliminating perhaps 30 to 40% of your energy bill. But it comes with a great deal of complexity. And a lot of the messages I've heard today are spot on. This is going to drive greater need for automation and automated responses. And I have to assume, we work with all nature of data centers, so I'm not talking about a company that has 30 data centers all tied together in one big cloud, such that they could lose a data center and still continue operations. I'm looking at the enterprise world as well. My responsibilities in Silicon Valley are primarily for the web giants. So I'm having a mechanical background, I'm heavily involved in some of the emerging technologies for cooling systems, primarily evaporative cooling, and tie that into raising the temperature in your data center for your equipment. I have customers right now, and I'm aware of, I believe it's Deutsche Bank in Germany, that are operating their data centers in the 90-degree range. And there's a good reason I won't go into why they pick that temperature. But the point is, as you do that, you're shrinking your margin for error. Again, driving the need for automation to help manage those environments. So the point is that there's a lot of changes taking place in data centers, whether it be applications, IT equipment, open compute has helped drive some of that, to the facilities infrastructure, to raising temperatures. We're changing everything at once. I couldn't think of a greater scenario where we need to focus on risk and risk management. So this is where my focus is, but it's primarily around reducing energy consumption for business value. So I'm going to take a little bit of a left turn from a lot of the discussion that's been going on today around IT infrastructure. Although IT infrastructure and the management of that, it has to be integrated in with facilities management to properly manage data centers of the future.